So we're going to talk about the laws of indices today. So what are indices? So indices are just powers of numbers. So for example, 2 to the power of 3, that's how we write it. We put a little 3 just at the top right of the number. So 2 to the power of 3, we say that the 3 is called the power or the index of the number. And what 2 to the power of 3 means is 2 multiplied by itself 3 times. So 2 to the power of 3 is 2 times 2 times 2, which is 8. Or more accurately, 3 2's multiplied together. So there's a set of laws we can use when making calculations involving indices. And we're going to go through them all in this video. The first law is x to the power of n times x to the power of m is equal to x to the power of n plus m. So what we're saying here is that a number raised to the power of n times that same number raised to the power of m is equal to that number raised to the power of n plus m. The second law, a number, or x, raised to the power of n divided by that same number, x, raised to the power of m, is equal to x to the power of n minus m. So when we're multiplying, you add the powers, and when you're dividing, you subtract the powers. So we're going to go through 2 examples that illustrate these and show you why this is the case. So if we're asked to calculate 2 to the power of 2 multiplied by 2 to the power of 3, we use law number 1 because we're multiplying, and all we do is add the powers. So 2 to the power of 2 times 2 to the power of 3 is equal to 2 to the power of n plus m, the powers added together, 2 plus 3, which is equal to 2 to the 5, which I believe is 32. Let's show you why this works. So if we actually write what these mean, so we know that 2 to the power of 2 is 2 2's multiplied together. So that is 2 times 2, put that in brackets, that's what that is. 2 to the power of 3 is 3 2's multiplied together. So what we're doing is we're multiplying that. But as you can see, we now have 5 2's. And this is the exact definition of 2 to the power of 5. So we're asked to calculate 6 to the power of 7 divided by 6 to the power of 5. We're using second law here. We can say that 6 to the 7 divided by 6 to the 5 is equal to 6 to the power of 7 minus 5, which is equal to 6 to the power of 2, or 6 squared, which we know is 36. Now let's see why this division rule works. So if we were to write these out, 6 to the 7 is equal to 6 times itself 7 times. So 7 sixes, 1, 2, 3, 4, 5, 6, 7, divided by 6 times 6 times 6 times 6 times 6. The top here is equal to 6 to the 7, and the bottom here is equal to 6 to the 5. And what we can immediately notice is that 6's cancel like that, leaving us at the top with 6 times 6, which is exactly 6 squared, which is 36. So this is why the division rule works. So when you're dividing, you subtract the powers. When you're multiplying, you add the powers. So let's get on to the next law. X to the power of n, all raised to the power of m, is equal to x to the power of n times m. So when you see brackets like this, you multiply the powers together. So let's do a quick example. So we're asked to calculate 4 to the power of 3 times 4 to the power of 4 divided by 4 to the power of 5, all to the power of 3. Well, let's just do this one at a time, and let's use what we've already learned from the first 2 rules. We know when we're multiplying, we add the powers. So we can rewrite this and say that it's equal to 4 to the 3 plus 4, which is 7, divided by 4 to the 5, all to the power of 3. And then we can use the division rule, and we know that when we divide powers, we subtract the powers. So this is just 4 squared to the power of 3. And now we can use the rule we've just learnt. When we got the brackets, we multiply the powers together. So we get 4 to the power of 2 times 3, which is equal to 4 to the power of 6, which I believe is 4096. Right, let's do our next example. So here we're asked to calculate 3 to the power of 3 divided by 3 to the power of 5. Let's use our division rule. If we remember from the other side, dividing means you minus the powers. So what we get is 3 to the 3 divided by 3 to the 5 is equal to 3 to the power of 3 minus 5, Well, 3 minus 5 is minus 2. So that's equal to 3 to the minus 2. Well, this looks strange. We haven't really talked about negative powers yet. But let's have a look at what this actually is. If we write this out, 3 to the power of 3, that's 3 3s. Whoops. Multiplied together. Divided by 5 3s. So 3 to the power of 3 divided by 3 to the power of 5 is just this. Again, we can cancel. Those 3's cancel. So what is left is just, on top is just 1. And the bottom is 3 times 3. This equals 1 over 3 squared. So what we have here is that 3 to the minus 2 is equal to 1 over 3 squared. Because these two are the exact same thing, just written in different ways, right? This one we use the formula. This one we've written it out in long. So what it looks like is that this minus sign, all it's telling us to do is to put a 1 over the whole thing. So what we have, we can just quickly write 3 to the minus 2 equals 1 over 3 squared. Right? And this leads us very nicely onto our next law. A number to the power of minus n, so x to the minus n, is equal to 1 over x to the n. This is exactly what we've shown just here with x equal 3 and n equal 2. This also implies that x to the n is equal to 1 over x to the minus n, of course. So let's do another example. We're asked to calculate 31 to the power of 3 divided by 31 to the power of 3. Well, that's strange. We know that any number divided by itself is equal to 1. So we know that that's 1. Let's quickly use our division formula as well. Because we're dividing, we subtract the powers, so we get that 31 to the 3 divided by 31 to the 3 is equal to 31 to the power of 3 minus 3. Well, that's just equal to 31 to the power of 0. We have that 31 to the power of 0 is equal to 1. And we can say that this is true for any number. It doesn't have to be 31. It could be 28, a million, 2, minus 4. Anything divided by itself is always going to be 1. So if we raise two numbers to the same power and divide them, we're always going to get 1. So we can always say that anything raised to the power of 0 is 1. Which we can say is law number 5. X to the power of 0 is 1. So any number you take, if you raise it to the power of 0, you get 1. And that's why. This example kind of explains why. So we have x over y, all to the power of m, is equal to x to the m over y to the m. So, for example, we're asked to simplify here. We're using a lot of the things we've actually learnt. So we're multiplying here, so we add the powers. 2 plus 3 is 5. So that is equal to 2 to the 5 divided by 3 to the 4, all to the power of minus 2. And now, note, we can't use the division rule here because these numbers aren't the same. Remember, the number that's being taken to a power has to be the same for the rules to work. So we can't say anything here. But what we can do is use the rule we've just learned. When a power is outside the bracket, you can bring it inside. So this is equal to... So we're using this rule here and the bracket multiply rule, where when it's outside the bracket, you multiply the powers. So this will be equal to 2 to the minus 10 over 3 to the minus 8. And if we think back to rule number 4, x to the minus n is equal to 1 over x to the n, then we can say that this is equal to 1 over 2 to the 10 divided by 1 over 3 to the 8. Like that. If we multiply the top and the bottom by 3 to the power of 8, this 3 to the power of 8 cancels, so we just get 3 to the power of 8 on top. Multiply top and bottom by 2 to the 10. This goes, we get it on the bottom. So now onto our last rule. So we have that x to the power of m over n is equal to the nth root of x to the power of m. So what this implies is that x to the half, so m is 1, n is 2, when we put that into our formula, we get that x to the half is equal to the square root of x. So this is something really important to know. X to the half equals root x. So let's do a quick example. So if we're calculating 27 to the 2 over 3, what we do is we take the cubic root. That's what the 3 here means. So the 3 is the n. X is 27. And we're squaring it, just like that. We get that this is 9. Another way of thinking about this, which is definitely a better way to approach this, because if you haven't got a calculator and you don't want to be working out 27 squared, because that's going to take a lot of your time, and then to calculate the cubic root of that is also going to be very long. What you can do is just notice that 27 to the 2 over 3 can be rewritten as 27 to the 1 over 3 squared. Because remember, when we move it in, we multiply. So 2 times 1 over 3 is 2 over 3. So let's just have a think as well about what 27 to the 1 over 3 means. We know that x to the half is the square root of x. So x to the 1 over 3 would be the cubic root of x. All we're working out here is what number times itself 3 times is equal to 27. And this is the kind of thing, when you do a lot of practice on this, you're going to start to spot these very quickly. But even now, you can just try out some few numbers. If you try out 2 times 2 times 2, well, that's 8, so it's not that. 3 times 3 times 3, well, that's 3 times 3 is 9, 9 times 3 is 27, so there you go. So what this is equal to is 3 squared, which is 9. A much nicer way of coming to the solution. What I'd always recommend doing, or most of the time recommend doing, is dealing with the bottom number first, and then squaring to get your answer, because I think it's much easier to do it that way around. Right, last example of this video, much harder. We're going to use pretty much all the things we've learned in this video. We're going to bring them all together to perform this calculation. So something like this looks incredibly intimidating, but if we just use all the right laws in the right places, it can actually be a very, very simple problem. So let's deal with the first one first. We'll worry about the multiply at the end. So 4 over 25 to the power of minus 3 over 2. What we know about minus signs is that they flip the numbers over. They put 1 over that number. And 1 over 4 over 25 is 25 over 4. So we can say that this is equal to 25 over 4 to the 3 over 2. So just to clarify, getting rid of the minus sign flips the division. Now we can use law number 6 here to bring the m inside the brackets, to get rid of the brackets. So we can say this is equal to 25 to the 3 over 2 divided by 4 to the 3 over 2. Well, again, let's just deal with these one at a time. So 25 to the 3 over 2. Well, we know that's equal to 25 to the half cubed, right? So what this gives us is, we know anything to the power of half is the square root of that thing. 25 to the half is 5. And that's the power of 3. 5 to the power of 3 is 5 times 5 times 5, which I believe is 125. So what we have on top here is 125. Now let's work out 4 to the 3 over 2. We have 4 to the 3 over 2 is equal to 4 to the half cubed, right? Because when there's brackets, you multiply in. 4 to the half is 2. 2 cubed is equal to 2 times 2 times 2, which is equal to 8. So what we have is that this is equal to 125 over 8. Now let's deal with the second one. 8 over 27 to the 1 over 3. Again, we can bring the 1 over 3 inside. So the cubic root of 8, remember 1 over 3 is the cubic root, as opposed to 1 over 2, which is the square root. So what number times itself 3 times is equal to 8. So again, you can just go through 2 times 2 times 2, there you go. So this is equal to 2, because 2 times 2 times 2 is 8, divided by, well, we just went over this one earlier, the cubic root of 27 is 3. So that's just 2 over 3. So our final answer will be, well, not quite, but 125 over 8 times 2 over 3, which is equal to 250 divided by 24, which is equal to 125 over 12. But yeah, that concludes this video. There was quite a lot to take in, so feel free to come back or do just a few laws at a time until you're really comfortable and then move on to the next law. Something like that. But yeah, thanks for watching.